Hello, everyone. I'm going to talk about a two proportion Z interval. So you can pause the video and try this on your own, and then look to see if you got it correct. So let's read the example. It says cigarette taxes have seen a big increase in recent years, so they must have quite a bit of support during the election, but this support likely comes from non-smokers. How much more do non-smokers approve cigarette taxes when compared to smokers? An independent research group takes a random sample of 605 non-smokers and 195 smokers. When asked if they support raising taxes on cigarettes, 351 non-smokers said yes, and 41 smokers responded yes. Create a 95% confidence interval for the true difference of proportions between smokers who support cigarette taxes and non-smokers who support cigarette taxes. All right, so we are trying to estimate the true difference between smokers and non-smokers who support the cigarette tax. So a two proportion Z interval is very similar to a one proportion, only we're going to have two proportions to look at, and we're going to look at the difference between the two. So what I did is I highlighted in blue the sample size for non-smokers. So out of 605, 351 said yes. So I went ahead and created that p hat, which is a sample proportion, 351 over 605. Now, anytime you have 351 that said yes, that means you have 254 who said no. So in total, the two add up to one. So I have my p hat and my q hat, and I put a little subscript of N to indicate that is non-smokers. But of course, you can call it any symbol you like. On your calculator, when you use it, they have sample 1 and sample 2, or proportion 1, proportion 2. So I went ahead and called this N for non-smokers. And then I went and did the same thing. I pulled out the proportion for smokers. So it was 41 out of not 195 voted yes, which means 154 out of 195 voted no. The first thing we want to do is state and check our conditions. So both samples were taken randomly. It says so in the paragraph. We want to show independence, so we can assume smokers and non-smokers are independent of one another. If you recall the condition of the NP hat greater than or equal to 10, so we have 351 and 254 are greater than or equal to 10, and 41 and 154 are greater than or equal to 10. You could see it is just the numerators of our proportion. In our last condition, we can assume there are more than 6,050 non-smokers and 1,950 smokers in the population. So we basically state and check the conditions for each proportion for each sample, the non-smokers versus the smokers. Once we have done that, we say conditions met, and we will use a two proportion confidence interval. In your formula sheet is the mechanics is the formula. So you can write it in words, which I did right here. Statistic plus or minus critical value times standard deviation of stat is equal to our lower bound and upper bound. Now I also wrote it in symbols. And so the only thing that is new here is that instead of our sample or our statistic, which is from a sample, being a one proportion, it's from two proportions. So we are going to find the difference between the smoker proportion and the non-smoker proportion. But in this case, we'll do non-smoker first minus smoker, since that is the larger one. So I'm going to go ahead and show you how to do that on the calculator. So looking at our calculator, the first thing we're going to do is go to menu, statistics. We're going to go to confidence intervals, and then a two proportion Z interval. From here, it guides us for our first, we can see our first fraction, x1 over n1. That's our first proportion. We are going to put the non-smokers first. So I'm going to go ahead and write 351 over 605. And the second proportion was the smokers, which is 41 over 195. Now, if you're wondering which proportion to put in first, it doesn't really matter as long as you're consistent. So if you're going to put, I like to put the higher proportion first. That way the difference is positive. And I know I'm comparing the non-smokers to the smokers. And if you do it reverse, then you're going to get a negative interpretation. So as long as you're aware of that difference. All right, I'm going to go ahead and keep it at 95% confidence level. And here are our results. Now, if you look at the P difference right here, if you were to enter the smoker sample first, you would get the exact value but negative. And then if you looked at the lower and upper bound, they would be the exact values but negative. So the interpretation would be slightly different. All right, so let's take a look how we can write our mechanics. What we see on our calculator screen right here. So we can see our lower bound, we can see our upper bound, we could see our sample difference, which is our statistic. So it's going to be right here is the difference between non-smokers minus smokers. So in other words, p hat of non-smokers minus p hat of smokers. That gives us 0.3699. I went ahead and put that there. Our critical value, which is our Z crit, is simply finding the critical value as we did previously for even a one proportion interval. Since we're looking for 95%, so in the middle is 95%, that means we are left with 2.5% on either tail. So in your calculator, you go to distribution and do inverse norm for the area of 0.025, which gives us a z-score of negative 1.96. So our critical value is 1.96. So I went ahead and wrote that over here. Now, the new thing is our standard deviation. Instead of doing a standard deviation for one proportion, you're going to do the same thing, but for two proportion. So I went ahead and look at the P hat, Q hat over N. This is for non-smokers, so I put the little symbol N, plus P hat, Q hat over N for smokers, so I put the symbol S. Looking at our proportion here, we can see that it is 0.58 for non-smokers who voted yes, and 0.21 for smokers who voted yes. So those are written right here. You can see in the under the square root of 0.58 times 0.42. Remember that adds up to 1 all over 605 plus 0.21 times 0.79 all over 195. And then our lower bound is given here, 0.300499. Upper bound, you can see, you could round, use 4 decimal places. And then from this, what does this mean in our conclusion? We can say we are 95% confident that the true difference between smokers and non-smokers who support the cigarette tax is between 30.05% and 43.93% higher for non-smokers than smokers. Now, if you were to do this in reverse, then you would still have the same results. If you would enter the sample of smokers first, you would get a negative result, and therefore you would say that it is 30.05% and 43.93% lower for smokers than non-smokers. That would be the only difference in the interpretation. All right, so hopefully this wasn't too bad. Go ahead and take a look at this. Try to do this on your own and compare my results with yours.